I thank each one of you for watching my videos all these years and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of December 2023. This question is from the section Partial Differential Equations, and the question is related to the solution of a given first order nonlinear partial differential equation. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 704095. Right. The given question is, let capital B is equal to the set of ordered pairs x comma y belongs to R square such that x square plus y square less than 1 be the open unit disk in R square. Del B, that is equal to the set of all ordered pairs x comma y belongs to R square satisfying x square plus y square is equal to 1 B, its boundary, that is the boundary of B, and B bar is equal to B union the boundary of B, that is B closure. For lambda belongs to the open interval 0 comma infinity, let S lambda be the set of twice continuously differentiable functions in B that are continuous on B bar and satisfy del u by del x whole square plus lambda times del u by del y whole square is equal to 1 in B, and u of x comma y is 0 on the boundary of B. Then which of the following statements are true? We are given 4 options. Option 1, S1 is lambda, that is for the value of lambda is equal to 1, S lambda S1 is empty. Option 2, S2 is empty. Option 3, S1 has exactly one element and S2 has exactly 2 elements. Option 4, S1 and S2 are both infinite sets. Let us now discuss the solution of the problem in detail. We have capital B is a set of all ordered pairs x comma y belongs to R square satisfying x square plus y square less than 1, which is a open unit disk in R square. Del B is the boundary of B, and B bar is B union del B, the B union boundary of B, that is B closure. And the boundary is the circle, unit circle. For lambda belongs to 0 to infinity, so lambda is coming from the open interval 0 to infinity, and S lambda is a set of twice continuously differentiable functions. It is twice continuously differentiable functions. They are differentiable functions and twice continuously differentiable functions in B that are continuous on B bar and satisfy this first order nonlinear partial differential equation del u by del x whole square plus lambda times del u by del y whole square is equal to 1 in B. Call it as the equation 1. It is the first order nonlinear partial differential equation. And u of x comma y is 0 on the boundary, the second condition. Let's call it the second equation. Right. So we first find the solution of the equation 1. That is the solution of this first order nonlinear partial differential equation. Now del u by del x, that is ux square plus lambda times del u by del y, that is uy square, is equal to 1. In a standard terminology, we have ux is p, uy is q. Right. Then this equation becomes p square plus lambda q square is equal to 1. That is f of p comma q is 1, where f of p comma q is p square plus lambda q square. It is a first order nonlinear, because of the square terms, partial differential equation. It is in standard form 1. In many standard textbooks, we denote the partial differential equation of the form f of p comma q is equal to 1 as the standard form 1. It is a function involving p and q only. Such forms are called standard form 1, and its solution is ready-made. U is equal to ax plus by plus c, where a and b are connected by f of ab, that is equal to a square plus lambda b square is equal to 1. I am sure that you are familiar with the standard form 1 and its solution. Now, f of ab, that is a square plus lambda b square is 1. From this, solving for b, we will get plus or minus under the square root of 1 minus a square by lambda. Then the solution is uxy is equal to ax plus by for b plus or minus 1 plus or minus under the square root of 1 minus a square by lambda, that is b, into y plus c. This is on b. On b, because we have solved that equation on b. Agreed. We continue in the next slide. The solution of 1, the equation 1 is here, is this one. uxy is equal to ax plus or minus under the square root of 1 minus a square by lambda y plus c on b. Now to find those solutions that satisfy 2. Second condition is here. On the boundary, we have x square plus y square is equal to 1. Observe that on this circle, 1, 0, 0, 1, the ordered pair 1 by root 2, 1 by root 2 are on the boundary. It is on the circle. They belongs to del B. So we take the equation and we substitute 1, 0 in this. So u of 1, 0, that is for x 1, for y 0 is 0. Why? On the boundary, your second condition is uxy is 0. So on the boundary, 1, 0 is an element, is a point on the boundary. Therefore, u of 1, 0 is 0. So also u of 0, 1 is 0. So also u of 1 by root 2, 1 by root 2 is 0. So u of 1 comma 0 is 0. So substituting in this solution, x is 1, y is 0, we'll get a plus c is equal to 0, that is c is equal to minus a. Right. Now u of 0 comma 1 is 0. So substitute in this equation, x is 0, y is 1, we get this plus or minus under the square root of 1 minus a square by lambda plus c. For c, you substitute minus a. Then you will get plus or minus under the square root of 1 minus a square by lambda is a. And solving for a, squaring, and solving for a, we will get plus or minus under the square root of 1 by 1 plus lambda. We go back to the solution. Then uxy is equal to ax plus or minus under the square root of 1 minus a square by lambda is a, right, a is a, y, plus c is minus a, right. Take a common, uxy is equal to plus or minus under the square root of a 1 by 1 plus lambda multiplied by, that is common, therefore x plus y minus 1. We have not used this condition, 1 by root 2 comma 1 by root 2 is on the boundary, therefore it should satisfy. So substitute x is equal to 1 by root 2, y is equal to 1 by root 2, then u 1 by root 2 comma 1 by root 2 is 0. So u of 1 by root 2 comma 1 by root 2 is 0. So substitute in this plus or minus under the square root of 1 by 1 plus lambda in brackets x 1 by root 2 plus y 1 by root 2 minus 1. This is simplifying, you will get plus or minus under the square root of 1 by 1 plus lambda. 1 by root 2 plus 1 by root 2 is root 2. Yes, 2 by root 2, that is root 2 multiplied by root 2 minus 1. We continue the argument in the next slide. So that is what we have. The solutions that satisfy the second equation, that is on the boundary condition, uxy is equal to 0. We get this one. We have seen plus or minus under the square root of 1 by 1 plus lambda into root 2 minus 1 is equal to 0. Right. Now look at lambda. Lambda is belongs to the open interval 0 to infinity. For any lambda, 1 plus lambda is not 0. And thereby under the square root of 1 by 1 plus lambda is not 0. And root 2 minus 1 is not 0. The product is not 0. Right? The product is not 0. A contradiction. So for any lambda belongs to 0 to infinity, we have under the square root of 1 by 1 plus lambda not equal to 0. So in this plus or minus under the square root of 1 by 1 plus lambda multiplied by root 2 minus 1, and root 2 minus 1 not 0, this is not 0, therefore the product is not 0, but we have it is 0, it satisfies. A contradiction to the above one. This contradiction shows for no lambda from 0 to infinity, S lambda has any functions in it. This shows that no solution of 1 satisfies the second equation for any lambda belongs to 0 to infinity. Right. If I take lambda is equal to 1, no solution. That is, S lambda consisting of the set of twice continuously differentiable functions on in B which satisfies the differential equation. Therefore, for lambda is equal to 1, S1 is empty. For lambda is equal to 2, S2 is empty, because for any lambda belongs to 0 to infinity, S lambda is empty. That's what we have proved. Therefore, S1 is empty and S2 is empty. Let's call the options. S1 is empty, S2 is empty. Appear against options 1 and 2. Therefore, option 1 is true and option 2 is true. And option 3 says S1 has exactly one element and S2 has exactly two elements. S1 is empty, S2 is empty. Therefore, option 3 is not true. Option 4 is also not true. Thus, the answer to this question, options 1 and 2, that is the detailed discussion of the solution of a given problem from the section partial differential equations, which is related to the solution of a first order nonlinear partial differential equation. The solution of a given first order nonlinear partial differential equation. It is not an easy question. It will be definitely a difficult question. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. And please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Happy learning mathematics. I wish you all the best. Thank you.